Hey guys, we are very near our end with our adventures in the quadratics and cubics section of A-level maths. There's one more technique we need to look at, and that is algebraic division. So this isn't things like x to the power of 5 divided by x squared. This is dividing quadratics or cubics, some polynomial, by either a linear expression or another polynomial. Now, I remember this incredibly well. When I was doing my A-levels, it's one thing our teacher said, it will never come up, so we don't need to go over it. Then in my exam, one of the very first questions, guess what it was? Algebraic division. And I remember my reaction went exactly like this.
Shit.
So, it does come up, it's still on the new syllabus. Now, it's quite notorious in the old maths world as being something that a lot of people really don't like, and it is quite tricky, to be fair. So, that's why I'm going to do 2 or 3 videos on it. I think at least 3, to try and get you guys to understand it and be able to do it confidently. So in this video, we're going to look at dividing quadratics by linear expressions. In the second, we're going to look at dividing cubics by linear expressions. And in the third, we're going to look at dividing cubics by quadratics. So, sometimes the thing that we are dividing by will fit exactly into the expression or the polynomial. Sometimes it won't, and we will get remainders, but we'll talk about that as it happens. Okay then, let's get cracking with our first example. Okay, for our first example then, we are doing x squared plus 7x plus 12 divided by x plus 3. Now, there is absolutely no reason with this one to use algebraic division. We can factorise this easily, but I like to start with simple examples and work up in our scale of difficulty. So, how do we do this? We first of all set it up as a long division. So we use a bus stop sign, x squared plus 7x plus 12 goes underneath, and our divisor goes on the outside like that. So, this, if you've not seen this yet, probably looks pretty mental. So let's go nice and slowly through it. We basically go through a 3-step process and we repeat it until we get all the way through. Okay, so first of all then, we do our first term underneath the sign divided by our highest power of x. So let's use colour to differentiate between our different stages. So our first term underneath the sign is x squared. Our highest power of x in our divisor is x. So we're doing x squared divided by x. Now that gives us x. And that then is our first part of the answer to put up on top of the sign, and it goes above x squared. So we get an x up there like that. Okay. Now, our second step is to multiply that by what we're dividing by. So, x times x plus 3 gives us x squared plus 3x. Now we write that underneath the original expression. So, x squared there plus 3x. And then we now subtract that from the original expression. So x squared minus x squared cancels out. 7x minus 3x gives us 4x like that. And now we're essentially doing 12 minus 0, which leaves us with 12. Okay, so we are now done with that original expression. We are now dividing 4x plus 12 divided by x plus 3. So let's change colour, let's go purple. So we now repeat that process. So we now divide the first term of 4x plus 12 by the highest powered x term of our divisor. So, in other words, we are now doing 4x divided by x, and that gives us 4. So 4 is the next term to put up on top. We then multiply that 4 by the divisor. So 4 lots of x plus 3 is 4x plus 12. Now we write that underneath the green expression now. So, now look, it's exactly the same. So we now subtract 4x plus 12 from 4x plus 12, and we end up with 0. Now, this 0 then tells us to stop. If this was any other constant on its own, that would also tell us to stop. This 0 tells us that there is 0 remainder. So, in other words, x plus 3 fits into x squared plus 7x plus 12 exactly. It fits in x plus 4 times. So this bit up on top is our answer. We can say, as we already knew, x squared plus 7x plus 12 is x plus 4 lots of x plus 3. There's no remainder. So there's our very first example, guys. Good times. Okay, for example 2, we are dealing with the same quadratic, x squared plus 7x plus 12. This time we're dividing by x plus 1. Now, x plus 1 is not a factor of this quadratic, so we're going to get a remainder. Let's see what happens when we have this situation up. So, again, we set this up as a long division. X squared plus 7x plus 12 in there, and this time x plus 1 on the outside. So, for our first step, we divide the first term underneath the sign by the highest powered x term in the divisor. So here, that is x squared divided by x, which gives us x. So that's our first guy to put up on top. Now we then multiply that by the divisor. So x lots of x plus 1 is x squared plus x. So we now write that underneath the original expression. So x squared plus x, like that. If you like, you could put a plus 0 at the end. You haven't got to, I'm not going to. So we then subtract this green expression from the original. So x squared minus x squared cancels out. 7x minus x is 6x, and then 12 minus 0 is 12. Good times. So this bottom green expression is now the one that we are dividing. So, we now do 6x divided by x. So 6x divided by x is 6. So that's our next thing to put up on top, like that. We then multiply our divider by 6. So 6 lots of x plus 1 is 6x plus 6. So we now put that underneath 6x plus 12. Like that. Then we do our subtraction. Now 6x minus 6x cancels out. So we just get 12 minus 6, which is 6. So our answer, x squared plus 7x plus 12 divided by x plus 1 is, what do we have up on top? We had x plus 6, x plus 6, remainder 6. So what we can also say, we could say x squared plus 7x plus 12 is x plus 1 lots of x plus 6 plus 6, like that. So if you were to expand and simplify that final right hand side, you would get exactly the thing on the left. So that's what happens when we get a remainder. Okay, now with one like this we can use the remainder theorem to check that our remainder is right. Remember, by the remainder theorem, if we were dividing by x plus 1, then f of minus 1 would give us our remainder. So f of minus 1 is equal to minus 1 squared, so positive 1, add 7 lots of minus 1, which is minus 7, and then plus 12 at the end, and that would indeed give us 6. So at this point, you might be thinking, well, what's the point in algebraic division if we can just substitute a value in using the remainder theorem? Well, in our recent videos, if you've been following them along, we've been looking at factorising harder cubics, where we use the factor theorem to find a linear factor, and then we equate coefficients to find a quadratic factor. Now, if we were using algebraic division, we wouldn't have to faff around doing that. So sometimes algebraic division is really useful, sometimes it's a right pain in the ass, but sometimes you'll be asked explicitly to use algebraic division, so it is a skill that we need. So let's do some more examples. Okay, for example 3, we're doing 2x squared minus 3x plus 5 divided by x minus 2. So let's set it up. So 2x squared minus 3x plus 5 goes in there, x minus 2 goes on the outside like that. Okay, step 1. The first term under the sign is divided by the highest powered x term in the divisor. So 2x squared divided by x. What's that going to give us? Well, that's going to give us 2x. So 2x goes up on top like that. Okay, times. Next, we multiply 2x by our divisor. So 2x lots of x minus 2 is going to give us 2x squared minus 4x, like that. So we then write that underneath the original expression. So 2x squared minus 4x, and then we subtract the green one from the blue one. So 2x squared minus 2x squared cancels out. Okay, times minus 3x minus 4x is minus 3x plus 4x. So that's going to leave us with an x there, and then effectively we're doing 5, take away 0, so we're left with x plus 5, like that. Good times. So that is now the expression that we are dividing by x minus 2. So we do the first term divided by the highest powered x term in our divisor. So x divided by x. Now that's going to give us 1. So that lives up on top. Then we do that multiplied by the divisor. So 1 lot of x minus 2 is just x minus 2. So we then write that underneath the green expression. And then we subtract the purple expression from the green expression. So x minus x is 0, 5 minus minus 2 is 5 plus 2, so we get positive 7. So our answer here is 2x plus 1. So I'm going to write this now at the end. Our answer is 2x plus 1, a remainder 7, like that. Good times. Now remember, you can always check your answer. If we are saying that 2x squared minus 3x plus 5 divided by x minus 2 is 2x plus 1, remainder 7, then we are saying that x minus 2 times 2x plus 1 add 7 is the same as our original quadratic. So 2x squared minus 3x plus 5. So if you want to check, expand the left hand side, simplify, and you will get the original expression. If you don't, in one of these questions, then it's cocked up somewhere, go back through, check your answer. It has to be exactly the same. Okay, next up we're going to do x squared minus 9 divided by x plus 3. So, set it up. What's going on with that too? So x squared minus 9 divided by x plus 3. Okay. First step then. The first term under the sign is divided by the highest powered x term in our divisor. So, in other words, we are doing x squared divided by x. And that is going to give us x. So that's the first jump to go up on top, like that. Then we do x times our divisor. So x times x plus 3 is x squared plus 3x. So we now write that underneath. So we got x squared plus 3x. Okay, now be careful here. In the top expression, we have a minus 9. We don't have any x terms. In the second expression, we got an x term, but no constant. So, we now do a subtraction. X squared minus x squared is nothing. Essentially now we have 0x minus 3x. So we're going to get minus 3x like that. And then minus 9 minus 0 leaves us with minus 9 there. So minus 3x minus 9 is now the expression that we are playing with. So we do the first term of that, divided by the highest powered x term in our divisor. So minus 3x divided by x is minus 3. So that's the next part to go up on top. We multiply that by our divisor, so minus 3 times x plus 3 is minus 3x minus 9. So we then write that underneath the green, minus 3x minus 9. Now we do a subtraction here, and what's going to happen? Minus 3x minus minus 3x and minus 9 minus minus 9 cancels out. We are left with 0. So our answer, x squared minus 9 divided by x plus 3 is x minus 3. With no remainder, which tells us x plus 3 is a factor of x squared minus 9. Okay, we're going to do one more. Okay, for our final example, we are doing 3x squared plus 2x divided by x plus 5. So, set it up. 3x squared plus 2x divided by x plus 5. Alright then, step 1, change to green. Step 2, the first term under the sign divided by the highest powered x term in our divisor. So 3x squared divided by x is 3x. So that's the first thing to go up on top like that. We then multiply that by our divisor. So 3x times x plus 5 is 3x squared plus 15x. So we write that underneath. 3x squared plus 15x, like that. Now we do our subtraction. So 3x squared minus 3x squared cancels out. 2x minus 15x gives us minus 13x, like that. Okay. Next we do minus 13x divided by x. Now that's going to give us minus 13. So that's the next thing to go up on top. Like that. Now we do minus 13 multiplied by x plus 5. And that gives us minus 13x. Minus 13 times 5, which is minus 65. Okay, so now we write that underneath the minus 13x. So we got minus 13x minus 65. So we're then doing that subtraction. Minus 13x minus minus 13x cancels out. So then essentially we've got 0 minus minus 65. So we end up with a positive 65 down there. So our answer is 3x squared plus 2x divided by x plus 5 is 3x minus 13 remainder 65. Okay guys, hope that's been useful. In the next video we will look at dividing cubics by linear expressions, and then in the third one we'll have a look at dividing cubics by quadratics. So hopefully this has made sense. If not, let me know down below in the comments.